Let us humble our souls for the word of prayer. Father, the Almighty, we thank you for the gift of life. We thank you for the protection you have given to us. We thank you for the food and love you have given to all of us. We thank you for the protection for our parents, Father. Father, we pray that this facilitation goes on well. Give blessings to our teachers who have put in the effort in this, I pray.
Amen. Thank you so much, Mazuri College Nakaseke, for taking us through the word of prayer.
We are through.
Okay, thank you so much, Teacher Sarah, for connecting us to Nakaseke. We are really very grateful for the effort and also bringing us close to you. We want to welcome all the schools that are joining in from the different parts of the country, and for connecting your students and all the head teachers. But we also want to thank the Research Network of Uganda and UICT, the Ministry of Education, and the Holistic Learning Platform for bringing us together for this session. Allow me to welcome the principal at the Ministry of Education and Sports, Mr. Ronald Dungu, to welcome the teachers on the call and to open up this session. Mr. Ronald, you are most welcome.
Okay. Thank you, Mr. Kaziba. I hope you can hear me.
Yes, you are clear.
Okay. Okay. Dear students and teachers, we would like to welcome you to yet another session. And this time it's a biology session. We've been online since last week, and we are winding up tomorrow. This is a pilot on closing the learning gap. And I think by the way things have been going, we have been able to showcase that it is possible to connect the whole of Uganda and they learn together. This Zoom session can host up to 500 people at a go, but we can even expand it to 1,000 schools. So if you can connect from Nakaseke to West Nile to Bushenyi to the east, then it means that anyone else can connect. As I speak, I'm even on the road, meaning that I can also learn as I move, as I drive on the road. And the other day I connected when I was crossing a ferry from Adjumani to Obongi, meaning that even in the middle of River Nile, you can still connect and study. So that is the reason why we set up these sessions, to ensure that we learn from them. So I want to thank the teachers who are organizing the students, and please take pictures to show us. I bring you greetings from the Minister of Education, who is concerned about the performance of biology. And we have a meeting next week on 10th, where we are meeting NCDC and UNEB to talk about the issues that were raised by the Association of Biology Educators, but also to pave a way forward. And one way forward is to connect the classrooms and have the teachers learning together, but also the students learning together. I also bring you greetings from the Permanent Secretary, Ministry of Education, the Commissioner for both government secondary and private schools, and all the friends of biology at the Ministry of Education, but also all the friends for the learners in this country. So I want to wish you a good session, and I will come back probably at the end to see the learning that has taken place, but I will be online all the way through. I thank Teacher Kugonza Arthur from St. Mary's College Isubi, who is presenting today, and also thank Holistic E-Learning Platform, Research Education Network Uganda, and Uganda, UICT for making all this possible for us. With that, I want to declare this session open. Thank you.
Thank you so much, Mr. Ronald Dungu. Allow me now to welcome Teacher Arthur to take us through the presentation. Teacher Arthur, you are most welcome.
Okay, thank you so much, Mr. Kaziba, and thank you so much, Mr. Dungu, who has left, but we thank him. Good evening, dear students and the teachers. I hope all is well. My name is Teacher Arthur Gonza, and I do teach biology at the St. Mary's College, Chisubi. So we send greetings to all of you. Today's session is going to be unique. It is going to be a practical session. In most cases, online seminars, we always pay much attention to the theory, yet there is another important area, and that is the practicals. And it is going to be hands-on. We shall need to write. The videos will have to be on because I'm going to do the demonstrations. We see how things can be done and how questions should be interpreted and how to write the correct observations and also make corrective conclusions. So that is today's session, purely practical. And practical in the sense of, because in most cases when we end up handling practicals theoretically, that when you write observations, do this and do that. So today is going to be theoretical. Allow me share the document that is going to guide us. So let me share my screen. Okay. I hope my screen is coming through. Can someone confirm that the screen is coming through? Mazolidi College Nakaseke, can you wave to me if the screen is coming through? Okay, yes, it is coming through. So that's what, okay, thank you. That's what you're going to do. Now, it is a guiding question. It is a guiding question. Yes, Bio Boniface, anything? Okay, not that. So it is a guiding question. Let me first minimize my video. Okay, so that is the question. We shall start with the number one. If time allows, it is a complete set of paper. So if time allows, we shall go through all of them. So number one, it is always about physiology. And physiology, it means that we are playing with chemicals. Okay, that's what I like calling it. We are playing with chemicals. So that is the question. They are saying you have been provided with solutions A and B, which contain food nutrients. Carry out the following test and record your observations. So with me here, okay. So with me here, I have my chemicals. I have my solution A. Of course, as a student, you may not know what solution A is, but I have solution A, it is here. Then I also have my solution B. They are just liquids in a bottle. They're just liquids in a bottle. So these are the solutions they're saying I'm going to work with. And they're telling me that they have food nutrients. So you also have to take note of that one, that they have food, nutrients. Then they want me to carry out food tests and record my observations and deductions. So now, if I'm to carry out the food tests, okay, then I record my observations. So you can note down that question so that we can move together. So you note down that question so that we can move together. Let me remove my video. So I'm allowing you time to record, to write down that question so that we can move together. Ideally 2 minutes are enough for us to write down that question. So I'm assuming we have finished recording it down. Then we can now go to the next slide. So this is our next slide. So also to move together, you first write down that question. To move together, you first record down that question. So I'm assuming that we have recorded down that question. Okay, so I'm now going to remove this slide to highlight my video, but I'm hoping that you have written down the questions, that when I'm reading the question, we are all following and we are seeing the observations that are taking place. Okay, so okay, so now the first question was saying that to 1 cubic centimeter of A added 2 drops of iodine. So this is my solution A, but we shall try to there. So I have my test tube here. So how do I know that I'm adding 1 cubic centimeter? So I will just get my solution. I just pour a little, just a little. And it is important that when you're pouring, you keep these things at your eye level, Even if I'm seated, I don't have to do it from down where I cannot see. Even or here or up. I just have that the video is off? Is it true that the video is off? Or the video is on? Can someone confirm, or it is someone's network? I beg your pardon?
The video is on, we can see you.
Okay, fine. So at my eye level, you see where my eyes are? At my eye level, that's where I do my things. But of course, not from here at a distance. So that because I want to see what I'm pouring in and also where it is going. So I'll do this. Just something like this. Just something like that. So that is enough. That is enough. Then they are telling me I add 2 drops of iodine. I have added, this solution you're seeing is not clear like water. You can even see it is looking like milk in the test tube. So this is what we call a turbid solution. A solution is either colorless or turbid. So this is a turbid solution. If it is not as clear as water, then it is a turbid solution. So this is my solution, it is turbid. Now I'm going to see if I add 2 drops of iodine, what do I get? So still, my iodine is here. So I'm going to get 2 drops using a dropper. I do this. That is 1, 2, I stop there. They told me to add 2 drops, not to add a lot, just 2 drops. So this is what I'm getting. I will shake a little bit. This is what I'm getting. Now, in the inbox, in the chat, which color is this that I have got? In the chat, which color is this? Let me see if I can try to cover the background to see if it can be visible. Yeah. So who can tell me in the inbox which color is this? This is what I have gotten after adding 2 drops of iodine. This is the color I have gotten. Okay, let me now check inbox. People are saying black. Okay. So I'll blend it again. Yes, it looks like black. Others are saying blue black. Others are saying blue solution. This, okay. So now I'm confident that now people can actually see what I'm doing here. Okay. So this, you can call it black. Actually, even when I see it, I can see it appears as if it is black. But again, when I shake, it gives me something like dark blue. It gives me something like dark blue on the walls of the test tubes. Now, if the observations are correct, so it means I have a blue-black solution or I have a black solution. This is what I have. Now, what do I write? We've seen that this is a blue-black solution or a black solution. Now, in most cases, getting an observation is different from writing a correct observation. That is where most of you always error. This is where my things are. So now, in this case, what do I write? So let me pause my video clip. Then I create a worksheet. I again share my screen, my document. Okay. Hope now my document is coming through. Okay. So my document is coming through. So we are answering Roman number 1. So now, whenever you're recording food tests, it is important to start by telling us the color of the solution you first had in the test tube. So because the question is saying, to 1 cubic centimeter of solution A, so I'm assuming A is already in the test tube. So what was the color of the solution in the test tube? It was turbid. So I will say the turbid solution turns to, so that's where I'm starting from, because the solution I had in the test tube was turbid. So I say, because I was observing the color change of the solution that I had in the test tube. That's what I was observing. So the turbid solution turns to, when I added, it turns to blue, I will say blue dash black solution. Another person saw black, which is also correct. Another person can say turns to black solution. Of course, you rate 1. You cannot have 2 observations at the same time. If for you in my video clip, you saw that it had some reflections of blue, then you saw blue-black solution. If you saw that it had black, then you have a black solution. Now, what are the most important points in this answer here? Surprisingly, the most important point is this one. I'm going to bold them, that word solution, and also this word solution here. If these words are missing, your answer will be discussed, whether to be accepted or to be denied. So why take chances? Always do the right, always do the right thing. If they are saying the word these solutions must be there, the word solution must be there, please put it there. Otherwise, I've seen students saying turbid, the turbid solution turns to blue-black, full stop. They'll ask you blue-black what? Blue-black solid, blue-black precipitate, blue-black gas, blue-black what? Because you can add and the turbid solution actually becomes a solid. That is an observation. But for us, we want to know what have you observed or what have you seen. So the word solution must be there. Close for me that door. Yeah. So then deduction. Now, how do I conclude? Now, when you're writing conclusions, you must quantify what you've seen. First of all, it is true. This is a confirmation that starch is present. This is a confirmation that starch is present. But you should always quantify how much starch is present. So because I got a blue-black solution, this signifies that there was much starch. A match here, we bold it. There was much starch present there. Now, you can also add and you get a blue solution. Now, the one I have got was not blue, was dark, more dark. And we don't rate that dark blue, you rate blue dash black. So if you get a blue black solution or a black solution, it means much starch is present. If you get blue, sometimes you can actually even add it and you get a pale blue solution, pale blue solution. So if you get a pale blue solution, it means that moderate starch is present. So instead of rating much, you rate moderate starch is present. So it is always important to quantify the food nutrient that you have found to be present. So that is what we have for Roman number 1. Then Roman number 2. So Roman number 2. So I have spotlighted my video again. Now Roman number 2, the question was saying, repeat Roman number 1 using solution B. So I have my solution B here. So I repeat the same procedure. The procedure was saying to 1 cubic centimeter of solution A, but now they are saying I repeat using solution B. So I add my chemical still at eye level. At eye level, you must see what you're adding and where it is going. And you see how I'm holding my test tube. I'm not holding it like this, because if I hold it like this, I will not be seeing what I'm adding. Where is it going? How much am I adding? You have to be, you hold it like this so that you can see the bottom, sorry, the mouth of the test tube and the bottom, because you have to see what are you adding, how much of it has gone into the test tube so far. So I will add something little, 1 cubic centimeter. I don't have to get a measuring cylinder to know what is 1 cubic centimeter. You add something little. So this is my solution B. So I want to, creating a white background, know that you're actually seeing the color of the solution that I am having. I think there now it is. Now, when you can, this one is clear. You can see that this solution is very clear like water. It is not like the first one. The first one was looking like milk. So this is clear. So this is what we call a colorless solution. This is now a colorless. It is as clear as water, this one here. Now they're telling me I add 2 drops of iodine solution. I have my iodine here. It is blue, it is brown in color. They want me to add only 2. Don't wizard and add more. So I pick my dropper, eye level. That is 1, that is 2. And make sure that your reagent does not fall on the walls of the test tube. It should hit directly into the solution. So this is what I have got. Very interesting. Actually, what I'm seeing on my screen is what I have got. So I want people to inbox me and tell me which color is that. Go to inbox and tell me the color you're seeing. Someone is seeing yellow. Which color is that? So this flower here is yellow. Is that color yellow? This flower here is yellow. Is that, are they of the same color? These ones here, are they of the same color? I also have a carrot here. We'll see if we can try to compare. Okay. Okay. Others are saying pale yellow, yellow pale. Okay. So now, if you see yellow, that is the correct observation. Those seeing pale yellow is also a correct observation. Others can say it is brown. Actually, me, when I look at it, it is even more brown than the pale yellow. Let's see. That is what I have. That one there. It is pale yellow, or it is yellow, or it is brown. So whichever observation, it is correct. So either pale yellow, you write what you have seen. What you have seen is what you write. So if it is pale yellow or brown or yellow, you write that. Now I'm going to see, then how do I write it? How do I write it? So let me open my document again. Okay, so still I have to start with the color of the solution that I had in the test tube before I added the reagent. So what I had a colorless solution. I had a colorless solution. That's what I had. I had a colorless solution. Then with this colorless solution, what did I see when I added my iodine solution? What did I get? So, because remember the practical, you are reporting your observations to the examiner. That's what you're doing. You're reporting the examinations, your observations to the examiner. A colorless solution turns to, I can even say turned to, it is correct. Turned to, people have said a yellow solution, turned to a yellow solution. If you have seen brown, you say turned to a brownie solution, turned to a yellow solution. Now, still, this word here that I'm bolding shouldn't miss. These words that I'm making bold shouldn't miss. They are very key, and you always tend to ignore them. We tend to ignore them. Okay. Now, I have had a very interesting question in inbox that is there a need to record the color of the reagent in the observations? Is there a need to record the color of the reagent in the observations? Well, you don't have to. You don't have to. The color of those reagents are already known. They are known. And even when we give them to you, even when the examiner is setting, they know, they'll give you iodine, which is brown in color. So you don't have to tell them that when I added brown iodine, we already know iodine is brown. For you, just add, just write what you see inside the test tube is what you write. You only write what you see inside the test tube. You only write changes that occur inside the test tube. Like the way I'm recording them, and there is no alternative way of writing these observations. Please take note. There is no alternative way of writing these observations. They are standard. Then now, how do I conclude now? Whenever you get a yellow solution, when you add iodine, or brown, or pale yellow, whenever you get this observation, this color, when you add iodine to a solution, it indicates that starch is absent. So here, starch is absent. That's what you read, starch is absent. Starch is absent. So we have finished Roman number 1 and Roman number 2. And you've seen how I have done these things. Now, whenever they ask you now, how have I known that it is a starch? Starch here. Why not proteins? Why not vitamin C? Iodine is used to test for starch. The moment they tell me to use iodine, then I automatically know I'm dealing with starch. That is automatic. Okay. So I think I have answered that question. It has come inbox. How do you get to know that you are testing for starch? I get to know that I'm testing for starch if they tell me to use iodine solution. That's when I get to know that I'm testing for starch. Okay. Then we proceed now to sorry, skipping the slides. I want to bring this one closer. I'm now going to Roman number 3. Roman number 3. Now, Roman number 3 is very interesting and technical. Let me again highlight my video to see what I am doing. Okay. Well, so Roman number 3 are saying to 1 cubic centimeter of A. For you, whatever step you read, you go to do. So I pick my test tube, it is here. They're saying I add solution A. I get back my solution A. This one here. Get my solution A. So They are telling me I add only 1 cubic centimeter. First of all, I have to make sure that my solution A is my test tube is very, very clean. So I will again wash it. I will wash it. Yeah, pour the water there. So I'm adding 1 cubic centimeter of solution A. So eye level and away from you, because you may pour chemicals on yourself. Some chemicals are acids, and some may stain your clothes or your uniforms. And you cry that you need another pair of uniform because you were reluctant, you were careless in the lab. So this is enough. I don't have to use a lot of chemical. Trying to see if I can, I think there, there it is, wonderful. So it is that one there. You can see it looks like milk. So this is a turbid solution. And this volume is enough. Don't add too much. When you add too much, you may not get some of the observations. Then they are saying I add now what? I add Benedict solution. Here we come. Benedict is here. You can all see it is blue in color. Now, Benedict's test for presence of reducing sugars. So when I hear of Benedict's, then I know I'm dealing with reducing sugars. So I'll get my dropper, a clean one. Now, I've not picked this one from iodine. Sometimes students in the lab, they pick droppers from another chemical, they use it in another chemical. Please, always leave droppers where they're supposed to be. If they have not given you a dropper, then you can as well pour. Actually, I'm going to pour. I'm not going to use a dropper. You can show that it is even possible to pour from this one here. So, eye level and away from me. So I want to add 1 cubic. So 1 cubic centimeter means I have to add the same volume as this solution I have in the test tube. Same volume. So I'll add. First of all, what I have here in the test tube is a turbid solution. That one is enough. So you see what I have. That one, very interesting, very interesting. I hope all of you are seeing the blue color that I'm seeing. So what have I seen? The turbid solution turned to a blue solution. So I first record that the turbid solution turned to a blue solution. So this is a turbid solution turned to a blue solution. Then now, from there, they now say I go and boil. So I'm going now to boil. Yeah, I'm going to boil. I have my source of heat here. Now the challenge will now be how I'm going to block the light so that we can be able to see the same observations here. We first see if I can try to change the direction of my computer away from the window, that I can see if my colors be very visible. No difference. There's no difference. Okay, what if I put it this side? There's no difference. Okay, anyway, I'm going to be showing you. So I'm now going to burn. Now, what am I having in my test tube? I have a blue solution. And what have I written so far in my observations? Turbid solution turned to a blue solution. So boiling, I don't have, of course, you have to use a holder. So I boil. So I boil as I remove occasionally to shake. I boil as I remove occasionally to shake. And when I'm boiling, don't boil directly at the bottom. Don't do this. Boil sideways. You see how I'm boiling? I'm boiling the sides of the test tube. I'm not boiling the bottom. If you boil the bottom, the solution will pop out and it may pop into your eyes. So you see, my solution is starting to boil and I'm still holding it with my hands. So if it gets too hot, it means I have boiled. And the moment it starts boiling, I hope you're seeing the bubbles. Are you seeing the bubbles? So if it boils, then that is enough. If it boils, then that is enough. Now let me show you what I have. That is still blue. It is still blue color. I hope everyone is able to see it. That is still blue. That is still blue color. That is the blue color that you get when you add Benedict to a solution A. Now, this is what I have gotten. Now, how do I continue with my procedures? The blue color remained or persisted. So what do I write? That the turbid solution turned to a blue solution and persisted on boiling. And persisted on boiling. Or I can say, and remained on boiling. Hope that one is clear. Then, that is now, for which I'll go back to the document where I'm writing from at once. Let me also first finish Roman number 4. Now, for Roman number 4, they're saying, I repeat the same procedure using solution B. Which procedure? Adding Benedicts and boiling. So I get my test tube. I have my solution B here. This is my solution B. I add a little. This one here. Don't add much. Add something little. Don't add much. I add my Benedict C solution. This time, let me use a dropper. But if you don't have a dropper, I have showed you, you can as well just pour. I aim at pouring the same volume of the solution that you have. So when I have poured, see what I'm getting. See what I'm getting. That solution is still blue in color. You can say blue, you can say pale. You can even ignore the use of the word pale. So this one, blue. So what have I seen? The turbid solution, so the colorless solution turned to a blue solution like that. Then I boil. Now going to boil. I remove and shake as I observe what is happening. If I notice anything peculiar, still boiling. Look at what I'm getting. I don't know why it is, I don't know why the reflection is changing it, but I have something green in here, which is now rapidly turning to yellow. I have something green rapidly turning to yellow. I hope you can see the green has disappeared. The green has disappeared. Now that green is visible when you boil as you shake and as you observe. So I'll continue with my boiling. So I first saw a green color, which disappeared quickly into yellow. Now I'm continuing with the boiling. So you boil as you shake. I think this is enough. Huh? So look at what I have. Very interesting. Look at what I have. Someone can inbox which color is that. Of course, that can't be yellow. That can't be yellow. I have an orange here. Which color is the orange? So I have, now here I've mentioned the color. I have a carrot here. Carrot is orange, so you can see they almost look the same. So this is orange. This is orange. Then let me continue boiling. I have a better source of heat down here. That's where now I'm boiling from. Otherwise, the other lamp I was using. Is it possible? You get me, Spirit. Put for me some spirit in there. So after thorough boiling, look at now what I have. Look at what I have. It is still appearing to you, to the screen. I'm seeing it's still appearing orange in color. So orange. So this is orange. It's very clear to everyone. Very interesting. Orange there. I hope you're seeing it. So now, which transitions have I seen? The transitions would be, now I'm going now to go to my document. We see how to code such an observation. Okay, let me start with the latest one. This one here, the last Roman number. I want to start with Roman number 4. So Roman number 4. So Roman number 4, what do we start with? Solution B was colorless. So I will say a colorless solution turned to a colorless solution turned to, now when I added my Benedict's in that test tube, it turned to blue. So it turned to a blue solution. It turned to a blue solution. Then the changes continued. The blue, I told you when I was heating, it turned to green. Green solution. Then the green solution quickly dissolved into a yellow. Dissolved to a yellow. Now, yellow is not a solution, but a precipitate. And I'm going to show you why. I hope we are able to see from ours. Okay. Okay, let me first pause this one a bit. I put back my video. Okay. Now, I have these two solutions here. Now, these two solutions, the yellowish one is not transparent. It is somehow thick. The yellowish one is somehow thick compared to the blue one. Now, the thick one is described as a precipitate. From the screen, as if it is not coming out clearly. So now the blue is what I got when I in my Roman number 3. Then that orange is what I got with my Roman number 4. So the orange one is a precipitate, because when you look at it in the test tube, it looks thicker. It looks thicker than what I have down. Looks thicker compared to the lower one. So I'm going therefore to record my observation like this. Turned to a yellow precipitate. Turned to a yellow precipitate, then eventually you've seen the yellow now changed to orange. Then orange precipitate. Orange precipitate, and stopped there. In some practicals, it can even go to brown. It can even go to brown. So this is what we have seen here. This is what we've seen. Now, how do I conclude? Now, remember, when they're using Benedict's, then I know this is reducing sugars. Then it means that now my reducing sugars are present. Reducing sugars are present. But remember what I told you here with the starch, that we had to quantify it, how much of it was present. I also have to do the same for reducing sugars. Now, when the color turns to orange, orange means we have much starch. Yellow, moderate starch. Green, little starch. Blue, now, pardon me, I'm saying the word starch, but it is supposed to be reducing sugars. So for orange, it is much reducing sugars present. This one here. Sometimes the color can actually stop at yellow. You boil and the color stops at yellow. Now, if the color stops at yellow, then you conclude by saying that moderate reducing sugars present. If the color stops at green, then you conclude by saying little or traces of reducing sugars present. If the color ends at blue, like we saw for our Roman number 3, Roman number 3, of course, solution A was turbid. Remember, a turbid solution, it was turbid solution turns to a blue, it turned to a blue solution, and persisted on boiling, and persisted. Now, I don't have to repeat the word on boiling. This word here, on boiling. I don't have to repeat this word, on boiling. Why am I saying repeat? Because the procedures told you to boil. So we know you have boiled. Why again do you tell us on boiling? We know you have boiled. So for you just say turbid solution turned to a blue solution and persisted, full stop. Then now if it remains at blue, then it means reducing sugars absent. I just read brief words like that. Don't have to write a paragraph there. Reducing sugars absent. Even here, much reduced sugars are present, even if I don't use the word are. I just say reducing sugar as present, just like that. So now here, don't forget the words I'm highlighting. Very, very important, yet easy to forget. Very important, yet easy to forget. Now we shall end this session at exactly 6. That's when we shall end the session at exactly 6. So please take note of the words I have underlined. They are very, very easy to forget, yet they are very, very important. Take note of them. Yellow and orange and brown are precipitates. The solution stops at green. Take note of that. Okay, so that was what we had to do. Now, for other food nutrients like proteins, if they tell you to use copper 2 sulfate and sodium hydroxide, then they want you to use to test for proteins. So that is how we do things. Now let me first attend to the questions in inbox, then we proceed. Now inbox, I have yes, Brian is saying that we should emphasize the use of a test tube holder. Yes, it is true. Whether you're seeing me, I'm using my hands. Why am I using my hands? First of all, I have done these experiments so many times. Therefore, I may not need to use a holder because from my experience, I can know when I have my final observation, even before the test tube gets hot. That's why I'm using a hand. But for you as a student in the laboratory, please don't risk using your hands. You'll burn yourself and even drop that test tube down and you end up not seeing observations. If you don't have a holder, then you can fold the paper. You can fold a piece of paper and use it to hold your test tube. But me, I'm doing it because I have overdone this. It is out of experience. So don't also copy me that because I'm using hands, you should also use hands. Okay. Then, thank you. How do I get to know that the given solution is either turbid or not? There is a question, how do I get to know that given solution turbid or not? Because when you use Irish potato solution, which is brownish, I thought it is one which we call turbid, but now I'm confused. Okay. Now, a turbid solution is that solution which is not clear. I can put it as simple as that. A turbid solution is that solution which is not clear. A colorless solution is that solution which is as clear as the water that you drink. Is a solution that is clear as water that you drink. Now, turbid solutions are confusing. They don't have color. They are not green. They are not blue. They are not red. But when you look at them, they are not clear. They are milky. So don't call them white. Don't call them milky. Call them turbid. Now, don't ask that. What if I say milky? Me, I'll ask you, what if you say turbid? Will you die? Others are saying, what if I call it white? I will again ask you, what if you call it turbid? Will you die? So turbid is that solution. Now I'll give you an example. Juice. So juice from lemon, juice from pineapple, juice from passion fruit. Please call them turbid. When you pound an Irish potato, it gives you some juice. Call that one turbid. Don't call them brownish. Don't call them yellowish. Just call them turbid. So I hope I have answered that question. it is a solution is either turbid or a food solution. A food solution is either turbid or colorless. Then what if I'm reading a question. What if I'm testing for starch and I don't observe a blue, black, or black solution or yellow solution? Yes, it is true actually. Sometimes you can add and the solution turns colorless. Sometimes it happens. You add a solution, turns colorless. Now, if you do that, repeat. It means you have added too much of something. Repeat and follow the procedures. You'll always get either pale blue, or blue black, or yellow, or brown. Okay. Then, is it okay on observation to say that the colorless solution took up the color of the iodine? Please. Then why don't we put 2 when we use tons? Now, let me again share my document and we see what I have done. 2 turns 2. A color solution turns, oh, I missed something here. A color solution turns 2. Hey, this one is 2. It was an error. Now, the way I have written my observations, please, I don't think it is very difficult to look at the format I have used. And I'm proposing, let us not pick alternative forms of presenting these observations. Scientific things are standard. Scientific things are standard. We report them uniformly. So do what you have seen me do here. Write them the way you have seen me write them. Don't develop options. Yes, your option can actually be correct, but I don't know it. I don't know it. So don't say the data told us all other options are wrong. No, you can actually have an alternative way of presenting this observation, and surprisingly, it comes out correct. But I don't know. Maybe what you think is correct is wrong. So please, let us follow this standard format. Let us follow this standard format. So don't ask the what if. What if I do this? What if I do that? What if I do that? I will again answer you. What if you do the right thing? What if you do this? Will you die? You will not die. So let us follow the standard way of presenting these observations. Okay. And there is a question, when preparing iodine solution, what question should be prepared? Iodine, of course, I'm not a lab technician, but the iodine we have, it is purchased it is purchased when it is already prepared. It is already diluted. It is already diluted. So always use the stock lab iodine. Don't dilute it. Leave it as it is. Then there is a question: what if a learner failed to rate much, moderate, or little? Will he or she be marked wrong? That is a very interesting question. Now, if you don't quantify, now, it depends on the marking guide. The marking guide will always have a mark for quantifying and a mark for the reduction, for rating the food nutrient present. So if there is a mark for quantifying, the learner misses out on that mark, but gets the rest. In some marking guides, there is no mark for quantifying. They just say, as long as the student says starch is present, they get a full mark. Then others, they'll say, for starch is present, half mark, match, half mark. So the word match gathers a mark, and the starch present also gathers a mark. So it depends on how the marking guide is designed. But let us not take chances. Let us always quantify where we can. Where you can't, fine. You never know. Maybe there was no mark allocated to quantifying, but all the rest will be marked correct. Okay, now I propose that I proceed with the question. The last one: how can I identify and differentiate a brown and orange? Now, brown and orange. Now, how can you identify that you have a brown solution or an orange solution. Now, because of time, I will not mix another one here. But however, brown is heavy. Let me use that word. Brown is heavy. Brown is heavy. Orange is light. Brown is heavy. Orange is light. That's what I can say. Okay, so for instance, I have these two colors here. So you see, one is orange, one is brown. So brown is always more darker. Though with these reducing sugars, you cannot get this form of brown. You cannot get it. But you get something close to that. But you always see that it is much, much heavier than the normal orange of the carrot. If it goes beyond the orange of the carrot, then it is brown. Okay. Mazoli Bikole, the hand is up. Is there a question?
Yes, we have a question.
Yes.
Yes, thank you, sir. My name is Visal Elismas from Mazoridi College. I want to know the difference between turbid solution and the white precipitate.
Okay, that is very interesting. Okay, thank you so much. Now, first of all, we use the word turbid on food solutions. We use the word turbid on food solutions. Before adding any reagent, we use the word turbid. So, because in the experiments, we always tell you to add a solution to the test tube. Now, once you have added that solution to the test tube, then now you start by taking a note. What is the color of your solution that you have just added in the test tube? And for food solutions, we are saying they only take up 2 colors. If it is not as clear as water, leave alone the colors, the 7 colors of the rainbow, leave alone the colors. But if it is as clear as the water that you drink, then it is a colorless solution. Then, if it is not clear like the water you drink, then it is a turbid solution. I'll give you an example. And of course, another point to note that something is turbid, when you shake it, you see it is thick. It has some particles in it. It is somehow thick. Like if you add flour to water, if you add chalk to water, you mix, you see it is thick. There are some solids in, then that is a turbid solution. If you get orange juice, you put it in a test tube. Since it is a food solution, to us, that orange juice is a turbid solution. Then, what of a precipitate? Now, a precipitate, you get a precipitate after there is a chemical reaction. You get a precipitate after a chemical reaction. Now, after a chemical reaction, when you get a solution, when you shake, you see it is somehow thick. It is somehow thick. Thick, not kind of transparent. Then you know that is now a precipitate. You know it is a precipitate if it is thick, but after a chemical reaction. So you have added a chemical, you shake, you see it is somehow thick, then you know it is a precipitate. Then another formula to help you know. Now, only use the word precipitate. Only use the word, if they confuse you now, when do I say that this is a precipitate, this is a solution? In the reducing sugar test and the non-reducing sugar test, the colors, yellow, orange, and brown, the state is precipitate. The colors, orange, yellow, brown, they are precipitate. Then all other colors on food solutions, on food test, are solutions. So also that one can help you. Never use the word precipitate unless it is a reducing sugar test or a non-reducing sugar test, and on the colors of yellow, orange, and brown, that one. So I hope the majority team I have answered the question.
Yes, we have one more, just one more.
Okay.
Okay. Thanks for the opportunity, sir.
Okay.
My question is, what if on boiling, directly turn to brown? So is my answer also correct?
Okay, it is a very interesting question. Now, that color can never turn to brown straight away. If it does, then it means you were boiling when you're not paying attention. Or you saw how I was boiling my things. I was boiling, I was doing this. I put, of course, now this one is off, the fire is off. I would put, then remove, shake, put back, remove, shake, put back as I observe. So when you remove, you shake, you see, is it turning? If you see it is not turning, you take it back. Briefly, you remove, is it turning? There, those colors are visible. They are there. They'll always be seen. But if I boil like this, I boil as I'm conversing with my friends. By the time I think of now seeing what I'm boiling, the color will already be brown. And for you to think that, oh, it turned from blue to brown. But all these colors always turn from blue to green to yellow onwards. And even if you have not seen them, because you are jazzing, write them. Even if you've not seen them, write them. That it turned from green, even if you do not see it, it was there, it is you was not careful. Write it out together. If you see the final color is orange, then you know in the middle there is a green, there is a yellow. Write it. And lastly, orange. If you finally have brown, finally, then you know that in the middle there, you had a green, you had a yellow, you had an orange that you are not able to see, but that color was there. So always write all the colors. Okay, so let me also go back inbox. Which solution do we use to test for non-reducing sugars? Now, non-reducing sugars, if in the procedures they have asked you to use these solutions, sodium hydroxide, hydrochloric acid, and Benedict's, those three, then you're looking for non-reducing sugars. And the observations are the same as those ones for reducing sugars. Then is it allowed to write the short form of the precipitate? No, write it in full. Write that word in full. You never know. They can say, now, this time we are not allowing short forms. So don't risk, write the word in full. Then, are there tests where you get precipitate apart from the reducing sugar? No. Precipitate, you only get them on reducing sugars and non-reducing sugars. In the others, maybe you can mix and you see something is becoming thick. Would be an error in how chemicals were prepared. Please only use the word precipitate for the colors that I have told you on reducing sugars and non-reducing sugars. Okay. Then, question, Master, are there tests? Okay, that one I have answered it. Is it allowed to write the short form of precipitate? I have answered it. Okay, thank you. Now, 52 minutes. We proceed, we have to proceed to finish the question. Then, where is my document? Okay. So that is it. So please adopt this standard way of writing whatever you write. What I have not, for example, if there is a way you know how this, you've seen how these conclusions, observations are written on this food test and I've not talked about it, please, you leave it. Adopt this method. The question was continuing. Now, they are saying, tightly tie one end of the visking tubing provided using the thread. So here, learners would be provided with a visking tubing. How does a visking tubing look like? Let me get one here. I've secured one. Just take a simple piece of paper, like this one. This is a visking tubing. I'll give it to you like this. Just take a small piece of paper, very thin. So they are saying, now, of course, when you're reading these procedures, read, comprehend, then again, repeat, read as you interpret. They're saying to one end of the visking tubing. Now it means that now, first I have to open this visking tubing. It is a polyethylene, but it's called a tube. So how do I open it? Opening it, I have to first soak it in water. So I have my water here. So I'll just soak it in. I'll just soak it in. And after soaking it in my paper, I try now to open it. It can be opened. So you see what I'm doing? I want to identify a point where I can open it. So it is open, but after soaking it in water, then with the help of the pen, you see? So it is coming out as a tube, you see? You see, that's, so opening it, you have to immerse it in water. Then you try to see how you can open it. So it is a polythene, like these ones, they used to pack nuts or sugar, but these ones are specifically designed for the lab. Like this, so that is it. So they are saying I tie a thread on one end. So I have my thread here. Let me put the water aside. I have my thread. So I tie on one end. Now, what am I doing? I'm following the procedures. I will put back to the slides and I show you. So I tie one end tight so that water cannot pass through. You can do it without even asking for the help of your neighbor. It is easy to do. You tight, make sure that it is tied tightly. Very tight, like this. Very tight, very tight. So I have something like this. It has to be opened. It's okay. Like this. There is no standard way of doing it, you just have to be creative. So I have something like this. Now, what am I trying to create? So I have something like this. This is what they call a visking tube or a visking tubing. We use them in experiments of osmosis and diffusion. These ones here. So now, so they are saying I mix two cubic centimeter of each solution A and B and pour the mixture into the visiting tubing. Of course, here I've put the visiting tubing may be weighted to open easy. Firmly tie the free end of the visiting tubing and wash the outside with water. Suspend the visiting tubing in a test tube half filled with distilled water as shown in the figure. So in other words, this is what you're setting up. If this thing comes in a practical paper, they'll always draw for you an illustration or a setup. So this is what we are trying to do. This one here is what we are trying to do. So in other words, even the instructions would be here. So the lower side is tightly tied with the whisking tube with a thread. Then I pour in a mixture of A and B. Then I also tie the upper end. Then I dip this mixture in a distilled D, in a boiling tube containing distilled D water. So I'm going to show you this one, how to do it, this one here. So just have the setup in hand, then we shall now discuss the theory of what is happening there. Okay, so this is it. So what they want me to do, they are saying, I now make a mixture of solution A and B, the other ones I have been using in the food tests, and they want me to make just 2 cubic centimeters. So I'll get this is my solution A. Now, here, use a measuring cylinder. Here, when they say 2 cubic centimeters, use a measuring cylinder. Use a measuring cylinder. So I use a measuring cylinder. So this is my 2 cubic centimeters. Then I also bring another 2 cubic centimeters of my solution B. So I measured, this is 2 cubic centimeters of solution A. This is 2 cubic centimeters of solution B using a measuring cylinder. So they are saying I mix them. So I mix them together. So this is a mixture of solution A and solution B, this one here. Then they are saying I pour it in my whisking tubing. So I pour it there. So I pour it. So I have this. So I have poured my mixture there. This is what I have. I have poured it there. Then I again tie the upper end tightly. So I'll tie this one. The upper end. I tie it with another thread. Must be tight so that the liquids inside don't seep out. Very tight, like this. So this is what I have. Of course, using a razor blade, a pair of scissors, I will trim off these hanging pieces of the thread. So this is what I have. So you see, we started with the whisking tubing, which looks like this, just like a thin slice of paper, like this. We immersed it in water. We opened it. After opening it, following instructions, we poured there. I hope my video is coming through. Yes, it is there. Maybe network issues, like that. Now, what are they saying? They are saying from the other setup that I now put it in a boiling tube. Of course, they are saying I first wash it. So using water, I wash it. I'll just immerse it in water to wash it. Like this. So I'm assuming it is now washed. Then now I put it in a boiling tube. So I push it in a boiling tube like this. Of course, I have to leave the hanging piece of thread where I can easily remove it. So I have this. Then they are saying I pour there distilled water. So this is my water here. So I'll pour in. So I have this. You see? And this is now the setup that was there in the question. This is the setup that was there in the question. So I have duplicated what I have in the question. That one there. And what is that in the question? This one. So I have duplicated this one here. I have duplicated this one. So I have followed all these steps the way they are. And then they're saying, leave the test tube to stand for 25 minutes. So I leave my setup to stand for 25 minutes. Now, do I really have to wait for those 25 minutes? Do I now sit down and start jazzing, waiting for 45 minutes? Remember, the paper is for 2 hours. Now, what you do, you time yourself 25 minutes. Then now you proceed with the other questions. You proceed with the other questions as you wait for the 25 minutes. Now you can be now going to number 2 of the exam of the paper or number 3. But after the 25 minutes reach, then you stop. Then you come back to your setup for number 1. Now, you're not going to wait for the 25 minutes. See what happens here. Now, we are going to use the theory to let you know that actually it is even possible to crack these things with the theory, to crack them. So you will just go to carry out the experiments just to confirm what your theory already has. What is that? Now, let us look at this question here. Let us look at this question here. Now, the question is saying that now let us see what do you expect to get? What do you expect to get? Remember, you don't have to forget the identity of your mixtures A and B, which you got here. So from this table, we already know what is mixture B, and we already know what is mixture A. We know that mixture A is actually starch. Then mixture B is actually reducing sugars. That one we now know. Why? Because in A, starch was present, yet in B, starch was absent. Then when we tried to find out about reducing sugars, we discovered that with reducing sugars, they were absent in A, but present in B. So now we know what A is and what B is. We know that A is starch and B are reducing sugars. Now, after waiting for 25 minutes, then what are they telling us? Carry out these tests. Now, we shall again not repeat these tests here, but we are going to use a very interesting method. Let me do this. Let us assume, okay, this is actually what happens. When we use the iodine test, of course, now you know how to carry out the iodine test from table 1. Now, iodine test, and what are they saying? They are saying that after 25 minutes, carry out this test on the water in the test tube. This water here, the water in the test tube, is now what we pick out. After 25 minutes, we remove our viscous tubing, we throw it. Then we remain with our distilled water in the boiling tube. Then we carry out tests on this boiling sorry, on this distilled water. So now, when we carry out the iodine test, we are trying to find out, is starch present in that boiling, in that water? If we carry out the Benedict's test, we want to find out, are reducing sugars there? That is it. So in this experiment, here I expect to find starch absent. And now don't ask me how, but actually when you carry it out and you carry out those tests, here, now of course, this is water. Remember, you're carrying out these experiments on water, and water is colorless. So here, a colorless solution turns to other people will see yellow, other people will see yellow, a brown solution. That word solution is very important. Don't miss it. Then when you get that, it is a confirmation that now starch is absent. Then here on Benedict's here, let me first minimize this. On Benedict's, the colorless solution, why is it colorless? It was water. Colorless solution turned to a blue solution when you added Benedict's solution. Then the blue solution turned to green. Green is also solution. Green is also solution. Then from green, it will turn to yellow. I told you yellow is a precipitate. That one, even if you don't know how to tell a precipitate, just know that just cram that yellow is a precipitate. And also orange is also a precipitate. Orange precipitate, like that. So take note, precipitate here, precipitate, solution, solution. Those words should not miss. Then it means the conclusion is that reducing sugars are absent. Are they absent? They are present. Reducing sugars are present, like that. So this is what you would get. Now, now this one is easy. Now the hardest part now comes. Explain your results. Explain your results. That is now where the hardest part comes in. And people will always miss these notes, these marks, yet they are for free. Explain your results. Okay, so let us look at now this part C. How do you explain these results? Now, explain your results. Your explanation should capture explanation of questions or of observations in practicals or in experiments. They should always capture 3 points, hence the 3 marks. The first point will tell us what happened. What happened? When you finish telling us what happened, how did it happen? How did it happen? Then why did it happen? Now, to me, this is what I think happened. Remember, here, what does it remember? Initially, we had this was distilled water, isn't it? This was distilled water. But after 25 minutes, mixture B crossed into the distilled water, and mixture A did not cross. That is why starch was absent, because remember, starch is mixture A. So the reason why starch was absent is because it did not cross the whisking tubing to go into the distilled water. But reducing sugars in mixture B, crossed. Isn't it what happened? Yes, because when we picked out the water from the boiling tube, we found starch was absent, which is true. It was never there. It was distilled water. But something very interesting, we are also finding that actually now reducing sugars are actually also present, yet they were not there. So the question is, where have they come from? Does distilled water contain reducing sugars? The answer is no. These reducing sugars in solution B must have crossed this visking tubing. Now they want me to explain this observation here. So what happened? Or what did I see? Because they're saying explain my results. Reducing sugars. This is what I have seen from the table. Reducing sugars are present in distilled water and starch is absent. That is what happened. Sorry, you see now I'm also confusing here. What happened? Let me copy this one and put it here. It's supposed to be here. It is there. What happened? Reducing sugars were found in distilled water and the starch was not there. Then I'll keep on asking me, are you sure? Yes, this is what I have seen. Reducing sugars are there, but starch is not there. That is what happened. That is what I have seen. This, what happened, you can also mean the observation. That is what I have seen. Then, how did it happen? How did this one happen? Reducing sugars. But how does it happen? How is it possible that you fail reducing sugars in distilled water, yet it was not there? Also reducing sugars moved through the semi-permeable visking tubing. And starch did not. And starch did not. That is how it happened. That is how I came to find reducing sugars in the distilled water. Reducing sugars were able to move through the visking tubing. Then now, how did that one happen? Why? Now, the why part of it. Why? Why is it that reducing sugars move through and starch does not move through? Now here the answer is in the theory. I will even open for you the notes and I show you that these things are actually there, only that sometimes you don't read. Why did it happen? Reducing sugar molecules are small. Starch molecules are big to pass through the visking tubing. Now these points are explaining my observation. But now, do I write them like this? Now, writing them, don't include this. I will delete this. Then I delete this. I can put a full stop here. Then I also delete this. So my answer becomes like that.
Mr. Kugonza, reducing sugars are present in distilled what?
Oh, sorry, thank you. In distilled water. Then also here, I do this, full stop. Now, this is now my complete answer. This one here. Now, when I read through it, let me see. They are saying, explain my results. Reducing sugars are present in distilled water and starch is absent. Reducing sugars moved through the semi-permeable whisking tubing and starch did not. Reducing sugar molecules are small, starch molecules are big to pass through the whisking tubing. Now, this point, someone can even write this.
Mr. Gonza, make reducing sugars capital at the start.
Okay. Thank you. Like that. So now this answer here, the English in it is not much. It is actually brief English. I have not used things like because, whereas, blah, blah, blah. That is not our point. For us, we are interested in, if I'm marking this answer, is the student telling me what he observed? I can see it in the first statement. Reducing sugars are present in distilled and starch is absent. First marking point. Then, is the student telling me how this one happened? The reducing sugars must have moved through the whisking tubing membrane and the starch did not. I put another marking point. Now, is the student giving us a reason why it is only the reducing sugar molecules to pass through and not the starch molecules? Yes, the student is saying reducing sugar molecules are small, starch molecules are big, pass through the whisking tubing. Then the student has all the three marking points. It is not about the English, it is about the quality of the answer that you have written. And how was I able to construct this answer? First, knowing that an explanation question is asking me for three things. What did I see? How did it happen? And why did it happen? That is why most explanation questions carry 3 marks on them. The first marking point is for telling us, what did you see? Then the second marking point is, how did what you see happen? Then the third marking point is for, give me a reason or tell me why it happened that way. That is the explanation. That is the explanation. That is the explanation. Then here, state the process that leads to the results obtained. Of course, this must be the diffusion. This is the diffusion. Now, whenever they give you to use whisking tubings, it means that you are either investigating the process of diffusion or the process of osmosis. Whenever you enter more practical, you find whisking tubing, put in your mind, you're investigating osmosis or diffusion. If it is about changes in volume, then it is osmosis. If it is about movement of these molecules that you confirm by carrying out food tests, then you know it is diffusion. Now, and these things, these practicals, they come from the theory. I'm going to show you in the notes where this thing comes from. I'm going to open the notes here. You see, actually it is a senior 2. That is a senior 2 topical question. Senior 2. So I'll go to transport. I'll go to transport. Transport is here. Experiments under diffusion. So this is the diffusion here. These experiments, look at these ones here. There is this one here. Experiments show that diffusion takes through an artificial membrane. You put only glucose. Then after you carry out the food test on the distilled water, you find the glucose will be there. meaning that diffusion has meaning that glucose molecules have diffused. Then the one the one in the captured there is here. So look at this setup. Inside we have a mixture of starch and glucose. Now, reducing sugar is glucose. Then now, let us read here. We see they are saying when a mixture of starch and glucose solution is put into the whisking tubing and placed in distilled water, only glucose molecules pass through the whisking tubing membrane, but starch molecules do not. This is because glucose molecules are small, thus can pass through the semipermeable membrane. But starch molecules are large, hence can't pass through a semipermeable membrane. That thing is interesting. So you can imagine the whole practical question has come just from that paragraph there. And the first marks are like free marks, carry out food tests, add this, what do you see? You just give us, those are free marks. So you should never fear practicals. They come from the theory notes that you have. Then there is also a note here. Sucrose and maltose molecules don't cross semipermeable membranes because their molecules are also large, since they are saccharides. So it means that now, if they give you a mixture of glucose and sucrose, it is only glucose that will pass through. Sucrose will not, maltose will not. Why? The reason is the same. Their molecules are large. Now, that is why when we eat the food, like, for example, when we eat posho has to first be digested for your body to get it. And the digestion is the breakdown of complex molecules into simple soluble molecules that can be diffused, or that can diffuse through the membrane of your cells. That is why the glucose, the starch in the posho you eat, has to first be digested to maltose in the mouth. Then that maltose proceeds and goes to the duodenum. In the duodenum, this maltose still cannot enter your bloodstream. Why? Because it can't diffuse, its molecules are large to diffuse through the membranes or the linings of the small intestines. Again, this maltose has to be broken down into glucose, smaller molecules of glucose that can now easily pass or diffuse through the membrane of the small intestines. That is the instance of digestion. They can actually even ask you in this practical question, they can ask you the daily life application of these things here, of this observation here, of this observation, the daily life application of this observation here that we have seen. It means that now large molecules in our bodies cannot diffuse through semipermeable membranes. Therefore, they must first be broken down into simpler or smaller molecules that they can now diffuse or they can pass through the semipermeable membranes. That is the significance. Of course, it was not asked here, but they can ask you. Then now, in such numbers, the questions that follow may not be necessarily the practicals. These ones here, they may not be necessarily the practicals. They now go back to the theory. State the process that is theoretical. The process we said is diffusion. State the importance of this process. So it means you now have to go back to the theory and find out what is the importance of diffusion in plants. What is the importance of diffusion in humans? And all those things are always taught by the teachers in class. Here, significance of diffusion. So you look through the ones for plants are the ones for, and the ones for animals. That is always what is captured in number 1 questions. I think for the interest of time, So today we have only been able to look at a demonstration of the number one question. Of course, time is never enough, but we have gone through the whole paper. I had actually even thought that we shall be able to get the whole paper, because I had even gotten the specimens, the flowers. So the teachers, I hope the teachers taking interest in taking students through the flowers. This is a very interesting area in practicals. I prepared the flowers here. Of course, there is the carrot. My students did this paper as the internal mocks, and I got a comment from one of the students that actually surprised me. One of the students, of course, in one of the questions about the carrot, we told the students, cut transverse section through the carrot. Longitudinal, not transverse, but longitudinal, where they had to split it open like this. Then we told them, put a drop of iodine on the surface of the carrot, of the specimen. What do you observe? Of course, the drop turned to blue-black, indicating that the carrot had starch in it. Then now we ask the students, okay, now, what is the importance of the specimen basing on that observation? And of course, the importance will now be that now this specimen stores food for the plant, because plants store their food in form of starch. So if this carrot contains starch, then it means that it is storing food for the plant. Then now we told our students to draw. They have cut the longitudinal section, then we're now telling them to draw. Now after the paper, one of the students said that her teacher, how comes in the notes we've never seen a drawing of a carrot? Teachers don't have to teach each and everything. It is a practical. Practical, they are skills. You just have to get the specimen, follow instructions, observe, and write what is asked of you. How hard is it if you split open? You just draw what you see. You make a simple sketch, of course, not forgetting the normal procedures of drawing, biological drawings. Sharp pencils, no sketches, something like that. So those are something interesting that you can practice out. You can get a carrot, get flowers. Try to go through them. I had several flowers of them here. This is a morning glory. Sorry, this is a hibiscus flower, common in practicals. This is the cassia flower, common in practicals. I had also the Irish potato. I don't know whether you know that this is a very interesting specimen, the Irish potato, stem tuber. Very interesting questions from it. They can also ask you, you cut transverse. Then you also add a drop of iodine. What do you see on it? The iodine, of course, will turn blue, black, or will turn black. What does it mean? It means that now this specimen is storing starch in it. Then, if it is storing starch in it, what is its importance to a plant? It stores food for the plant. Then, how is it adapted to carry out that function? It is swollen, as simple as that. On plants, parts that you see to be swollen, it means that they're storing food for the plant. They're either storing food and water or only food. So the adaptation of this one is that it is swollen, implying that it is storing food and water for the plant. Even the carrot is swollen, meaning that now it is storing food and water for the plant. That is how these two specimens here are adapted to their functions. The function is storing food for the plant. And how are they adapted? They are swollen. As simple as that. Then, of course, this one can be used for vegetative propagation. Why? It has buds. It has axillary buds. It is storing food that can be used by the sprouting young one. The young ones, when they are sprouting out, they need food because they have not yet made leaves to carry out their own photosynthesis. So they rely on the food that is stored. That's why most of the parts of a plant that are swollen are used for vegetative propagation. The food that they have is used by the sprouting plant during growing. I don't know if they germinate. I think it is seeds that germinate. This one just sprout. So things like that. So of course, time can never be enough to exhaust all the biology. But I'm hoping that now we have gotten some skills, and it is these skills that help us to do other things. Okay, let me check inbox for
Teacher
some
Arthur,
questions.
we are asking, are you available on a Saturday? Is it possible? Saturday, maybe some hours in the morning, and are the schools and learners available?
Specifically, this Saturday is not possible.
Okay, okay.
But we can always plan. We can always plan, but this Saturday is not possible.
Okay, then we can go with this, and maybe in the future we shall come back after mocks, because I can imagine the learners, but I leave it to the comments in the chat.
Okay. Plant biology practical challenges us. Now for plant, actually, plant biology practical, they shouldn't challenge you because all the practicals are condensed in one topic like this, one topic, and that is the senior one topic. Let me open the notes here. You see, these are the senior one notes. Now, the topic is a structure of flowering plants. The topic structure of flowering plants. This topic is taught in senior one. This is where all the practicals on plant biology come from. All the practicals, this topic here, and it is very short. So learners can go back, read and revise this topic. The questions here are very rare in theory, Why? Because they know in practical, it is a whole number. And the reason why sometimes students have a challenge with this same topic here is because they learn these things in senior. Probably by now, most of them don't even have these notes. They don't. By the teachers, if you check those students' notes, you may read that you may find that they don't have senior notes, and that is where the practicals come from. Look at the topic here, the topic before, insects. This topic of insects, practicals come on insects. Actually, most of the senior work is where the practicals come from. And these students don't have the notes. They don't have the notes. They'll even tell you that they never learned those things. So all the practicals come from here. All. Let me show you now the Irish potato. The Irish potato. It is here. They can tell to draw. How is it adapted? You see, swollen with large amounts of stored food, has scales and accelerated buds which form eyes, which sprout into new plants. Onions, just one topic. So if you can revise this topic, then you may not have challenges with the practicals of plant biology. Was I sharing the screen? Let me check. No, I was not sharing the screen. Let me share, sorry for that. I was showing that all these practicals, they come from this one topic. Plant biology, they come from this one topic of structure of flowering plants. These ones, you see, this is the topic. Others come from soil, also a senior one topic. Look at these, all these ones, they come in practicals. These ones, modified stems, ginger. The Irish potato is here that I asked about in that practical paper. How are they adapted. They are swollen with large amounts of stored food. They have scale leaves and axillary buds that sprout into new plants. That's why they're used for vegetative propagation. The onions, students may be surprised if they find an onion in a practical. Yes, Mr. Doom. Yes.
Is it possible for you to extract some of these notes and share them as a PDF to the learners in their schools? Because I can imagine somebody is struggling to look at these notes and yet they don't have the notes.
Okay, now the assumption was because these are the notes that actually are widely used by most teachers in the country. So the assumption was that at least teachers must have seen this document. Actually, all teachers online with WhatsApp, they must have seen these documents.
Because we might assume and they do not.
At least I tend to think that they have them. They have them. But nevertheless, we always share. We always share them. We always share. Because but at least I've found them. They're big use.
Now that we are dealing with the learners and the head teachers are the ones maybe struggling to bring them online, the teacher is not available. Maybe the head teachers now can do a small printout, even if it is one book, one document, and put in class for the learners to refer to in the last months.
Yes, okay, it is very fine. If I'm contacted via WhatsApp, I will always share.
Mr. Kaziwa could share these in one public space, and then the head teachers can start from there.
Okay, so I will also send them to Mr. Kaziwa, but also they can also WhatsApp me.
If you put your number in the chat, yeah.
Okay, so there are questions. I saw there was an open hand. So that is the number. Okay, Mike Ogasi, you are unmuted.
Yes, please.
Yes.
Can you hear me? Can you hear me?
Very clear. Very clear.
Thank you very much. Thank you very much. I want to appreciate all the time you have given us, but there is a concept on the Irish still. Here, an Irish is buried, is planted in the soil for 1 week. And then one Irish is picked fresh. And then learners are asked to obtain solutions, to crush them on a mortar and obtain solutions. I am well aware that the fresh Irish potato will contain a lot of starch. My concern is about this Irish potato that has stayed in the soil for 1 week, and then later on it is removed after 1 week and crushed. Then we are supposed to carry out iodine test and the Benedict's test. And then the last test is for non-reducing sugar. As a teacher, for me, I know all the processes that happen in the Irish when it is planted, because we need energies for sprouting of these young buds. That means the starch which is there is going to be broken down by the carbohydrates enzymes in
to have reduced.
Irish. Yeah, so there will be formation of maltose and later on broken down to glucose to release energy during respiration. Is that what is true about what I know? Because I needed to find out.
Oh, yes, it is true. You expect to find the content of starch will reduce as the content of the reducing sugars will be increasing. Why? Because for the sprouting plants to use the stored starch, they can only use it in form of glucose. So the stored starch has to first be converted to glucose, then the glucose used by the sprouting plants. That's why the content of reducing sugars would increase as the content of the starch reduces, because the starch is being broken down to reducing sugars for use by the sprouting plants.
Yes. Then maybe if I may inquire a little bit about a seminar of senior 6 A-level mostly, if there is any day that it could be organized for mostly A-level students.
In which region?
This is West Nile.
Okay, now we have one on the 7th of October at Ginger, all across at Ginger.
Yes.
Then we also have one in the Forteso region. It will be at Ngora High on the 30th of August.
Yes.
Then in West Nile, we are still trying to get in touch with the St. Mary's Ediofe girls.
Yes.
And also Mr. Luciano, a teacher there.
Yes.
To see if we can get a very good venue and a good day to have also one in West Nile. So those discussions are there.
Yeah, the good thing you have shared the numbers here, because I am more interested. I have candidates of senior 5 and 6, and ideally I would love to see that when that time comes, I think I'll be in position to come with all these students so that they see, they compare, and they build the confidence in what I have given them.
Yeah.
Yes.
Thank you. Then also, we also have an oncoming online seminar also for teachers, A-level. The day will be communicated in 2 weeks' time from now.
No, it's fine. I'll send you a message on WhatsApp so that you keep me updated.
Okay, fine.
I will definitely send a message on WhatsApp, then you keep me updated.
Okay.
Thank you very much.
You're welcome.
So which school is Mike?
I am from Cornerstone Secondary School, Arua City.
Are you attending with some learners or you are alone?
Yeah, for now I have moved away from school, but I have been attending with them because tomorrow, in fact, since the seminar started, I have been with them because tomorrow they are doing paper 2 of Arua City mock.
Oh, okay.
So they have picked everything. If the time we had this concept of the Visking tube and so on, they were just confirming what we have gone through.
Okay.
Yeah. Okay. So I think literally we've come to the conclusion of the seminar.
Yes.
Now, Mr. Kaziba, someone is asking for your number inbox as well. Otherwise, it has been a great pleasure to have a discussion with you and to share one or two things. And I hope I have put something, I've put some confidence to the learners in emphasizing or reinforcing what the teachers have been telling them or what they had not yet told them. And maybe some other last thing, the seminar for the TESOL region, which on the 30th of September, sorry, not August, 30th of September is for both levels, O level and the A level. The one which will be in Ngora, 30th September, is for both O and A levels. Over to you, Mr. Kaziba and Mr. Dungu.
Thank you so much, Teacher Arthur, for the wonderful presentation, and thank you so much for always coming to close the learning club in the field of biology. We are really very grateful to have you, and thank you so much for always sharing. We want to thank all the teachers and the students that have been on the call, and I'm going to ask those schools that are still on with their learners, kindly you can have your video on. Today we have been having about close to 45 schools that have been able to join online. We are really very happy to have you, and thank you so much for always joining in. We shall continue to have these sessions. Tomorrow we shall have ICT. We shall have an ICT. So please tomorrow feel free to join in for ICT. Those students that do ICT as their optional subjects, we shall have ICT. And then for A level, we shall have applied math. We want to thank you so much. And maybe for the teachers, we shall have a digital change agent meeting whereby we are going to get teachers and we shall take you through the roadmap that we are going to be following because we want every teacher in every school to be equipped with the ICT knowledge. So we want to thank you so much, and we want to let you know that we shall still continue with these sessions, and we want to ask the teachers kindly take for us photos now, like Greenwood High School. We are happy to have you, Kangulumira Public, Mary Assumpta. We are really very grateful to have you. Thank you so much, Kangulumira, Greenwood, and all the schools, Mary Assumpta. We are always happy to have you. Allow me now to welcome Mr. Ronald Dungu to have a word to us. Mr. Ronald, you are most welcome.
Thank you, Mr. Kaziba and your team. And thank you, Teacher Arthur Kugonza, for the time you have given to the learners and the teachers. I really felt that we needed more time, but we cannot have it. This was a pilot, and we have discovered that there is a gap to fill. And I'm happy that the biology team is organizing workshops across the country. But we shall also call upon you when we return from our holidays for maybe 1 or 2 other sessions in biology. Biology has been an injured subject, and we really need to see if there is a difference that can be made in a short while. The learners, of course, we note that there's been a lot of learning today, and there is still need to learn more, but we urge you to do whatever you can and read a lot before your mocks. I know some of you have already started mocks, but read a lot so that we see better performance than we have been experiencing. With that, I want to wish everybody a good evening. And for those who will come back for ICT tomorrow, we shall see you. But otherwise, we wish you wonderful mocks, and we are ready to support you all the way until your examinations. As Ministry of Education and Sports, we are committed to make sure that all learners across the country perform to their best. And that is why we are out here to see if there is something that can happen even online, and we will build from this pilot to yet bigger execution of this sort of learning. I want to thank everyone and declare this session closed. Bye-bye.
Okay. This is good.